In case K, we're looking at tire sales that a garage sells, and the person who's ordered these products has the sense that type A tires are twice as popular as type B tires, and that type B tires are twice as popular as type C tires, and that's the hypothesis that we want to test. So is that supposition plausible based on the data from last year's sales below? Um, the hardest part of this problem is making sure we understand what the null hypothesis is and getting the expected number according to our supposition of the different brand popularity is. In order to get that right, it's very important that we get the total number of, it's very important that we get the total number of sales here so that we can get the expected number. And if we add these three numbers together, 113 plus 82 plus 26, I got a total of 221 tires sold last year. And to get the expected number, we're going to have to use these relationships that are in the supposition. So let's write the null hypothesis. Our null hypothesis is that, don't know why I lost that. Null hypothesis is that the expected number for type A is going to be equal to twice as many as the number for type B, and the number of type B is going to be equal to twice as many as the type for brand C or type C, against the alternative hypothesis that H0 not true. So the alternatives are easy to figure out once we get the null hypothesis in goodness of fit test. And it doesn't tell us anything else, so let's go ahead and use an alpha of 5% so that we have a good balance between the possibility of type 1 error and type 2 error. And with that, the next thing we need to do is figure out how many we expect of each brand to sell. To get that, we would say that A is equal to 2 times B, and B is equal to 2 times C, but because of that relationship, we also would be able to determine that A would be equal to 4 times C. So we know that the amount that we sell for A plus the amount that we sell for B plus the amount that we'd expect to sell for C, when we have 221 tires sold, would have to sum up to 221. So using these various relationships here, I'm going to put 4C for A and 2C for B and C to get 221, or C is equal to 221 divided by 7, and that's equal to 31.57. And that's the expected number for brand C. The expected number for brand B could then be calculated as twice that, and when I did that, I got 63.14. And the expected number for brand A would be twice that, and when I did this, I got 129.29. Now, I'm writing down the numbers that I got. When I actually made the calculation, I wasn't rounding, but I did round here. When you add those three together, you should expect to get 221, the total number we actually sold, and we get that. So these three together, expected number in A, expected number in B, and expected number in C, those total 221. So next we need to calculate our chi-squareds. And for brand A, then we had an observed number of 113, so we'll have an observed, an expected, and then a chi-squared. Our observed number was 113. Our expected number was 129.29. And we calculate our chi-squared, as always, taking our observed number minus the expected number, square it, and then divide by the expected number. And when I did that, I got, for A, I got 1.5 399. For category B, I had an observed number of 82, an expected number of 63.14, which, oops, I lost a digit here. And that led to, for category B, that led to a chi-squared value that's pretty big. There's a significant difference between those. So 82 minus 63 squared, then divide by 63.14, and I got 5.634. And for category C, I had an observed number of 26, an expected number of 31.57, and a chi-squared of 0. That's supposed to be a 0.983. When I sum those, I got a value of 8.016. Now I have to compare it to my chi-squared crit. And for that, I need an alpha of 0.05 and a degrees of freedom equal to the number of categories minus 1. And I had 3 categories, so I have 2 degrees of freedom. So now I need to find that critical value, and I've actually found that before in an earlier example. Sorry, that's not the problem we want here. So I have 2 degrees of freedom because I have 3 categories, and I have alpha equals 0.05, so I'm looking for a chi-squared crit of 5.99, 2 degrees of freedom, and alpha equals 5%. Now back to our problem. Zoom back out. Oop, zoom back out. Too far. There we go. We got a chi-squared crit equals 5.99 from the table, and as our chi-squared is greater than chi-squared crit, we must reject H0 in favor of HA. So the supposition is not plausible, and we need to reject it in favor of the alternative that we don't really know exactly the preferences between type A, type B, and type C. But we do have demonstrated that the previous supposition is not valid, as demonstrated by last year's tire sales. End of case K.